Okay, in these experiments, these demonstrations, we're going to look at the low density gases, helium and hydrogen. I'm going to show you how to fill a helium balloon from a canister, and then we're going to do a demonstration about whether it burns or not using a normal spill, and compare that to hydrogen gas. And we'll do the hydrogen balloons twice, once in daylight and once at night. So many of you will be able to access helium cylinders. Even some supermarkets at Christmas have them, and people just don't know how to use them. They're fairly straightforward. They're not cheap, but they are straightforward. We've got a valve here and a valve at this side. So you just simply put the balloon over. These are actually helium quality balloons, not the cheapo party balloons. They're no good for this. And you just lower the valve down to inflate the balloon. And these balloons will go up a fair way. Let's get that out of the way. Next task, of course, is to knot the balloon. You may have technicians available to do that for you. And then to add them to a bit of string and tether them off. I'm going to tether them to the leg of this demonstration table. When you're trying to set fire to the gases in the balloons, you need to be aware of where you're positioning your balloons. Too close to a flammable material such as a wall chart here would not be a good idea. Under a data projector would not be a good idea. Under curtains on a stage if you're performing this as a party piece for a Christmas chemistry lecture demonstration is also not a good idea. Nor is it a good idea to simply try it with a spill up close. What we've done here is simply taped up a couple of spills to a meter rule. So we'll set fire, or attempt to set fire, to the helium balloon first. Let's light the spill off a Bunsen burner, which is a lot easier than trying to light it off a match. And all I'm going to do here is put the flame at arm's length under this side of the balloon. So here we go. You should know, of course, what you're expecting to see. And the answer is absolutely nothing, because helium has a full outer shell of electrons and is chemically unreactive. Let's try that with a hydrogen balloon. Here I've already tethered them to a water bottle to add us a bit of stability. Again, no overhanging flammable materials, mobiles or small children. And we'll try this at arm's length. A slightly different reaction. If we substitute the balloons over, we'll try this in the dark. I'm even turning my Bunsen out, and we can have the others away. And you can see there the volume of burning gas, which of course is created by the distance that the hydrogen diffuses in that split second before it shunts around the electrons in a whole complex mechanism of reactions. For those of you that don't have hydrogen cylinders in your school, you will never be able to inflate a hydrogen balloon with sufficient pressure to make a balloon that size float. You can't do it from a KIPS apparatus, you can't do it by reacting magnesium with acid, and you just won't have the pressure. You do need a cylinder. So unfortunately, if you don't have a cylinder of hydrogen, that's not going to happen.